Alright, here's another arithmetic question where it says that the first and second term of an arithmetic progression are 161 and 154 respectively. And they said the sum of the first q terms is 0. Find the value of q. So as it said, the first and the second term of the arithmetic progression are 161 and 154 respectively. So the first term, so this is for part A, right? Let me try and separate the space. I always like to just make a little bit of space. So just separating the space. So they said the first term is 161. And so they're telling us that the first term, we can call it A, is 161. Then the second term, as we know, is A plus D. The second term is A plus D is 154. So from these two, what we can gather is that therefore the common difference D is equal to the second term minus the first term. So D is equal to 154 minus 161. And so D is equal to negative 7. So that's the common difference, negative 7. Now it says the sum of the first q terms is 0. So the sum of the first q terms is 0. Now we just have to remember, so what they're telling us they know is that SQ is equal to 0. So SQ is equal to 0. The sum of the first q terms is 0. And so what that is telling us then is we just need to remember to find the formula for the sum of an arithmetic progression. And the sum of an arithmetic progression formula is given by n over 2. In this case, we're not using n, it is q. So it is q divided by 2 times 2a, 2 times a, where a in this case is 161. So 2 times a, 161, plus n minus 1. N in this case is q, so it becomes plus q minus 1 times d. Your common difference d is negative 7. And this part right here is equal to 0. So that's the equation we're solving. Q over 2 times this is equal to 0. So we just have to apply back the formula. So remember, we're applying the formula. Just to write it down again, Sn, the sum of n terms of an arithmetic progression is given by n over 2 into 2a plus n minus 1 times d. That's the sum of n terms of an arithmetic progression, right? Just to write it down right there. So now what we have right now is q over 2 times, this works out to be 2 times 161 is 2 times 161, that's 322. So we have 322 plus q minus 1 times negative 7. Q minus 1 times negative 7, well, that's just going to work out to be q times negative 7 is negative 7q. And then negative 1 times negative 7 is plus 7. So multiply those. So we have negative 7q plus 7. I will multiply everything together, we get equal to 0. So expanding in the bracket now, q over 2 times 322, that just works out to be 161q. And then q over 2 times negative 7q works out to be negative 7q, negative 7, q times q is q squared, so it's negative 7 over 2 plus now, well, oh boy, 7q over 2, and that's equal to 0. I could have simplified this earlier, but my bad. Now 161 plus 7 over 2. 161 plus 7 over 2. That is going to work out to be 329 over 2. So this is 329 over 2 times q minus 7 over 2 times q squared. And that's equal to 0. And so what that is telling me is that this implies if I were to factorize out q from both of them, then I'm getting 329 over 2 minus 7 over 2 times q. And that's equal to 0. I can also factor out the half instead of just factoring out q, just factor out q over 2. And so what we're getting then is actually 329 minus 7q equal 0. Now, from solving this equation, what we're pretty much solving then is that q over 2 is equal to 0, or 329 minus 7q equals 0. And so if q over 2 equals to 0, then this is telling us q equals 0. And q equals 0, this is not valid. This is not possible, because q equals 0, you can't find the sum of 0 terms, right? Then that would make no sense. So this is not possible. So this now make no sense. And so we have 329 minus 7q is 0. And so 7q is 329. And so q is equal to 329 divided by 7. So 329 divided by 7 is 47. And so q is equal to 47. So the value of q is equal to 47. So that's the value of q. Now the second part says a geometric progression with all positive terms has a common ratio of 0.8. Find the number of terms whose sum first fall below 90% of the sum to infinity. So it's a geometric progression with all positive terms of a common ratio of 0.8. So the common ratio is 0.8. Now it says find all the terms, or find the number of terms whose sum first fall below 90% of the sum to infinity. So let's do that. So I'm just writing down the information that they give us. So they tell us that the common ratio, so we have a GP, I like to write GP. They tell us that the common ratio R is 0.8. That's the first thing them tell we say. The common ratio is 0.8. So let's go back to the next part now. It says the common ratio is 0.8, right? And them say find the number of terms whose sum first fall below 90% the sum to infinity. So they're telling us that we can call the sum of the GP Sn, right? And they're telling us that find the number of terms n such that Sn is less than 90% of the sum to infinity. 90% of the sum to infinity. I'm going to call the sum to infinity as S infinity. And they want us to solve for n. So pretty much what they did is give us an inequality, and we're going to solve this inequality for n, where n is going to tell us the number of variables or the number of terms such that Sn is less than or falls below 90% of the sum to infinity. So let's look at the question again, just to confirm that that is what we're solving. It tells us that everything positive in the GP, the common ratio R is 0.5, and we want the number of terms which is n, whose sum first fall below 90% of the sum to infinity. So this is the information they give us. Now Sn, as we know it, Sn is A into 1 minus r to the n over 1 minus r. That's Sn, and it's less than 90%. 90% as a decimal is 0.9 of A over 1 minus r. So that's what we're solving. Now this works out to be, well, we don't know what A is, but we don't need to know what A is, right? Because when we have an inequality like this, the A's is going to cancel on both sides. So the A right here so cancel, the A right here so. How do I know that? For example, if I give you an inequality that 5 over 3 is less than 5 over 2. 5 over 3 is less than 5 over 2. The 5's cancel right here, and I would left back with an inequality that is telling me that 1 over 3 is less than 1 over 2, which is still correct. 1 over 3 is still less than 1 over 2, right? So we can cancel stuff like this. So we can cancel the A's on the both sides. So we can cancel A's on both sides. And so what we're left with now is the inequality 1 minus r to the n, where r is 0.8. So 1 minus 0.8 to the n divided by 1 minus r. Now 1 minus r is just 0.2, and it is less than 0.9 times 1 over 1 minus r. 1 minus r is 1 minus 0.8. So it's 1 over 1 minus 0.8, it is 0.2. Now this part on the right hand side is working out to be 1 divided by 0.2 times 0.9, and that's 4.5. So we have 1 minus 0.8 raised to the power n over 0.2. It is less than 4.5. So now we just need to make n the subject. So that's all we need to do. We just need to make n the subject, and then we're pretty much finished. So let's make n the subject. So we're going to take this and bring it all the way up to here. And so what we have now is 1 minus 0.8 to the n is less than, we can multiply through by 0.2 to get 0.2 times 4.5, that is 0.9. So 1 minus 0.8 to the n is less than 0.9. And so we can bring over 0.8 and bring over 0.9 to get 1 minus 0.9 is less than 0.8 to the n. And so what we're getting is that 0.1 is less than 0.8 to the n. And now remember, anytime the unknown is in the power, we're going to have to take the log of both sides. So we're going to have to take the log of both sides. So let's take the log of both sides now. So taking the logarithm of both sides, we're then going to get that the log of 0.1 is less than the log of 0.8 to the n. And so when we bring down the power n, we're getting n times the log of 0.8, and that's the log of 0.1 So to get n on one side, what we need to then do is divide by, so we need to divide through by the log of 0.8. And so the log of 0.1 divided by the log of 0.8, that is less than n. It is less than n. So the log of 0.1 being divided by the log of 0.8, the result is giving me 10.3. Result is 10.3, and that's less than n. So in other words, n is greater than 10.3. And so the smallest number of n, since n is greater than 10.3, then n must be equal to 11. That's the smallest number of terms. N is equal to 11. Because we're talking about terms, we're talking about sequence and series. So if n is greater than 10.3 terms, then n must equal to 11. And so what we can therefore say now is, go back to the question, is what we're pretty much saying is that find the number of terms whose sum first fall below 90% the sum to infinity. Then the number of terms is 11. So 11 terms whose sum first falls below 90% the sum to infinity. So the number of terms is 11. So n is equal to 11. Alright, n is equal to 11. Easy question, soft. Alright, so we're going to look at this final question now.